Friends, now we are solving a problem on multiple integrals. Now you see the given problem is evaluate double integral r sin theta dr d theta over the cardioid r is equal to a into 1 minus cos theta above the initial line. So this is nothing but a double integral. They are given here directly limits? No. So we need to find out the limits for this region. So what is the region they are given? Cardioid over the initial line. Friends, you know the cardioid shapes. We have two types of the cardioids. One is like this, another one is just opposite of this. Like these are the two cardioids we have. But r is equal to a into 1 minus cos theta is in this shape. Next, r is equal to a into 1 plus cos theta is like this, just opposite of this one. Now, so above the initial line they are asking. Now I will draw an xy plane. Now this is x plane and this is x axis and y axis. Sorry, x axis and y axis. So this x axis you can say like initial line. So now we have to evaluate the region is they are given the cardioid above the initial line. So this is initial line. Initial line. Now above we required, above the nothing but here you required only in this region. We have to evaluate this integrand in this region only. Now what are the limits we have? Here you observe the given problem. I will write first double integral of r into sin theta into dr d theta. Right. Now we have to integrate with respect to r and theta. Observe the given cardioid is r is equal to a into 1 minus cos theta. Now theta is nothing but, observe this graph. The shaded region is obtained in how many quadrants? 2 quadrants. So you can say the theta is from 0 to pi. In generally, if it is in first octant, only first quadrant, you can say 0 to pi by 2. In second quadrant, then you can say 0 to pi. In third quadrant also, if it is occupied, 0 to 3 pi by 2. If it is in 4 quadrants, if it is there, 0 to, yes, 2 pi. Now I want radius. How can I get the radius? Is nothing but here you see we have to draw one pole to get the radius. Generally you see y is equal to minus x line you write on, or else y is equal to x line you write on. R is a region. You see for this one, for this shape you see it is started, this is a curve, not like a circle, not like a hyperbola, okay, yes or no, not like a ellipse, like. So in this case the radius is started at 0 to, it is moving like this totally. So it touches the initial line like this. So you can say this is the radius is changing each and every point. So you can say r is started at 0, but it is moving along the a into 1 minus cos theta cardioid. That's it. So now the lower limit and upper limits you know. Now you can integrate this one very easily. Now limits from 0 to pi. And this is the theta limits. Now r is from 0 to a into 1 minus cos theta into whatever the integrand, r into sin theta into dr into d theta. That's it. So this cardioid is clear for everyone. If same problem, if they are given r is equal to a into 1 plus cos theta means like this only. Now in this case, first you observe we are doing double integral. While doing the double integral, we have to observe the limits. Limits are independent, or one is independent, another one is dependent. In this case both are not independent. So in this case what we have to do, we have to verify which is a dependent variable. So here r is equal to 0 to a into 1 minus cos theta is nothing but r is a dependent variable. So first we have to integrate with respect to r. This is the first. Next we have to integrate with respect to theta. This is second case. That's it. Is it clear? Now first I am integrating with respect to r. Then sin theta is a independent term of r. So r integration is r square by 2. Limits from 0 to a into 1 minus cos theta into d theta. Now integral from 0 to pi. This 1 by 2 I can write outside. Now I have a sin theta into a square into, if you applied the upper limit, then a square into 1 minus cos theta whole square. 1 minus cos theta whole square. This 2 already I have written outside. Next if you put 0, then you will have this term minus 0 is nothing but same term only you will have into d theta. Now 1 by 2 into, this is a square is also constant, so a square also I am writing outside. Limits from 0 to pi. 0 to pi sine theta into, you can split this one better to, before that you can write this 1 minus cos theta as 2 sine square theta. 2 sine square theta by 2 you can write. 1 minus cos square theta you can write 2 sine square theta by 2. So this is in terms of theta by 2. So this also you can change into theta by 2 term. D theta, this is whole square you have. So first I am writing the constants outside. This is 2 square is nothing but 4. So this is 4a square by 2, limits from 0 to pi, and this is, you have a sin theta. Sin theta, how you can write actually? 2 sin theta by 2 cos theta by 2 you can write, into, this is sin to the power of 4 theta by 2 into d theta. If you simplify this, then you will have this 2 getting cancelled, then 4a square integral 0 to pi sin theta by 2 into sin to the power of 4 theta is nothing but sin to the power of 5 theta by 2 into cos theta by 2 d theta. Okay, numerator 2 denominator 2 getting cancelled. Now I am writing the terms integral 0 to pi sin theta into sin to the power of 4 is nothing but sin to the power of 5 theta by 2 into cos theta by 2 into d theta. Okay, now you observe friends, this is sin to the power of 5 by 2 is there. So into cos to the power of 5 by 2, I can do this problem in two methods. I can apply the values method, or else bracket derivative, nothing but here if you have a formula f of theta, okay, let it be f of x power n into f dash of x dx if you have, then you can write f of x power plus 1 by power plus 1. That's it. You can apply this formula. So in this case you see 4a square integral from 0 to pi by 0 to pi. Now sin theta by 2 whole to the power of 5, I can write this as, what is the derivative of sine? Cosine only, that is cos theta by 2. But is the theta by 2 derivative is beside? No. For that what I am doing, theta by 2 derivative is 1 by 2. So multiplying 1 by 2 here and divide with 1 by 2. That's it. Into d theta. Now this is in the form of integral of f of x power n into f dash of x. Means bracket derivative is beside. Then you can write bracket power plus 1 by power plus 1. First I will write, you see this 1 by 2 will become a 2. So 8a square integral from 0 to pi sin to the power of t by 2 whole to the power of 5 by 2 into cos theta by 2 into 1 by 2 we have. Yes or no? Into d theta. Now I can apply which formula, means integral f of x whole to the power of n into f dash of x dx, that is equal to f of x power plus 1 by power plus 1. That's it. So 8a square into, now you can write this as bracket power plus 1 means sin theta by 2 power plus 1 is, this is 5 only, sorry, 5 plus 1 is 6 by 6. That's it. Now limits are what you have, 0 to pi, 0 to pi. Now in this case you will have 8a square by 6, 6 is outside. Now so if you put theta is equal to pi, then you will have sin pi by 2 minus sin pi by 2 whole to the power of 6 minus sin 0 power 6. Okay, 8a square means here 2 4s are 3, 2 3s are 6. So this is 4a square by 3 times of sin 91. 1 power 6 is 1 minus sin 0 is 0. Therefore this value this value is, that is double integral over r into sin theta into dr into d theta value is 4a square by 3 in the cardioid. Okay, is it clear for everyone? Thank you for watching this video.